Hi, welcome to RAR Math. Today I'm doing a series of videos on probability. This question says, what is the probability that a five-card poker hand has a single pair? So this is an interesting question because the first thing we need to do is get a pair. So if we thought about getting a pair of, say, fives, we separate out the 4 fives from the 48 original cards. So if I find the combination of getting the 4 fives, it's the combination of the 4 fives taken two at a time to get a pair. But the thing is, I'm not just looking for a pair of fives. I'm looking for any pair. So I need to actually multiply this by 13 because it can be any of the 13 suits. Okay, so this right here will get us all of the 13 possible pairs. But next we need to look at the other 3 cards. Now, when we deal the other 3 cards, we need to make sure that there are no more repeats. We've taken out the extra, say, fives, but for all we know, the next 3 cards will be 3 of a kind. So to ensure that they're all different, we take the remaining 12 cards. So if we took out the fives, the 12 cards are the ace through king minus the 5, and we pull out 3 of them. But this only really deals with 1 suit per card. So for the first card, we need to multiply by 4 because that first card can be any of the 4 suits. And so there's 3 cards. This gives us different ones. Times 4, any of the 4 suits. Times 4, any of the 4 suits. Times 4, any of the 4 suits. So the 13 is because there's 13 different numbers that could be a pair. Over here, we're multiplying by 4 because this time we're worried about the different suits. So if we multiply this all out, we get 0.4226 for this probability. The next question says the probability 2 cards are drawn from a deck of cards. What's the probability that they are not a pair? Okay, so if we're trying to figure out the probability that they are not a pair, you draw your first card and you have 12 options for the other times all the different suits, and then the second card, and it gets really convoluted for not having a pair. But if our set is not a pair, then the complement of that set is a pair. Well, calculating if 2 cards are a pair is a little easier. We did that up here in question number 7. We can calculate if we have a pair by taking the combination of 4 of a suit taken 2 at a time times 13 different suits. Well, once we have that for a pair, we just divide this by all of the possible 2 cards. So the whole sample set is the 52 cards taken 2 at a time. The thing is, this is the complement. So an event plus its complement equals 1. So if we subtract this complement from both sides, we get that the probability of event is 1 minus its complement. So 1 minus 13 times the combination of 4 taken 2 at a time divided by the combination of 15 taken 2 at a time gives us our final answer of 0.941. Okay, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!